Today, we're going to delve into the fascinating world of materials science and explore the differences between brittle, ductile, and plastic materials. To understand these materials better, we'll be examining their stress-strain curves, which are graphical representations of how a material responds to applied stress. A stress-strain curve plots the stress applied to a material against the resulting strain. Stress is the force applied per unit area, while strain is the change in length divided by the original length. By analyzing these curves, we can gain valuable insights into a material's properties, such as its strength, ductility, and elasticity. Brittle materials are those that fracture or break suddenly when subjected to stress without significant plastic deformation. Brittle materials exhibit a linear elastic region up to a point called the ultimate tensile strength. Beyond this point, the material fails abruptly, showing little or no yielding. Brittle materials are found everywhere around us. Glass, ceramics, and concrete are common examples. Even some metals, like cast iron, can exhibit brittle behavior under certain conditions. Ductile materials are those that can undergo significant plastic deformation before fracture. Ductile materials exhibit a linear elastic region followed by a yield point where the material begins to deform plastically. After the yield point, the stress-strain curve may show a plateau or a region of strain hardening before eventually reaching the ultimate tensile strength and then fracturing. Ductile materials are found in countless applications. Metals like copper, aluminum, gold, silver, lead, nickel, steel, and titanium are highly ductile and used for wires, pipes, jewelry, and structural components. Plastic materials are those that can be deformed permanently without fracturing, even at relatively low stresses. Plastic materials often exhibit a linear elastic region followed by a yield point, similar to ductile materials. However, after yielding, they continue to deform plastically without significant strain hardening, allowing them to be shaped and molded. Many of the polymers we encounter, such as polyethylene, polypropylene, and nylon, are the building blocks of plastic materials. All three types of materials exhibit an elastic region where they return to their original shape when the stress is removed. However, the extent of this elastic region varies. Brittle materials have a relatively small elastic region, while ductile and plastic materials can exhibit larger elastic deformations. Ductile and plastic materials both show yielding and plastic deformation, but the behavior after yielding is different. Ductile materials may show strain hardening, while plastic materials tend to deform more readily without significant hardening. Brittle materials fracture suddenly without significant plastic deformation, while ductile and plastic materials can undergo significant plastic deformation before fracturing. Understanding the stress-strain curves of brittle, ductile, and plastic materials is essential in various fields, including engineering, materials science, and manufacturing. By analyzing these curves, we can select the appropriate materials for specific applications based on their strength, ductility, and other mechanical properties.